Okay, this is the Calc 1 Exam 3 review, which somehow I never filmed all the times I had taught Calc 1. Very strange. So I thought I'd start with probably the easiest topic, which is on that test, which is the L'Hopital's rule. Now, normally you have to make sure that they are indeterminate, but I want to just give you this important warning. You do not need to show me this. I am not going to create one that is not indeterminate to try and fool you. This is not the way it works. You should, in your head, kind of check to make sure it's 0 over 0, like this first one. If you put 0 in for x, you get e to the 0, which is 1, and you get 1 minus 1 on top, which is 0. And then obviously negative 0 is 0, so you get your 0 over 0 here. This one, x goes to infinity. 7 times infinity is still infinity. Forever plus 9 is still forever. E to the infinity is infinity. So you do get indeterminate form. So once you see that, you can use L'Hopital's rule. So I like to just write the L with the H to indicate that I'm going to take the derivative. Even though I'm doing that, I'm going to do them separate. Now I want to point out, once again, when I first taught how to do limits, I made it very clear. You must write lim until you plug in. Once you're ready to plug in, you stop writing lim. I'm picky about this. It is important that you use proper notation, proper technique. So if you stop writing lim when it's supposed to be there, or you continue to write lim when it's not supposed to be there, you may lose points. So first I'm going to take L'Hopital. Now, why I picked this one, and 1B on the review sheet is similar to this. Taking this derivative requires a chain rule. Now, first mistake I see students do is instead of taking this derivative, they put a 1 there. But the derivative of 1 is not 1. So that's the first mistake. You got to be very careful. Screw up the whole question. The second mistake is when they take that derivative, they'll just put e to the 3x. But that's not the derivative of e to the 3x. It's a chain rule. The third mistake, they will forget this minus that's in front of it. So first you drop the minus down, right? The derivative of 1 is 0. Not going to write that. Derivative of e3x, chain rule, right? You do du, e to the u. So we're way beyond that, so I'm not going to go over it again. Look back at the chain rule ones if you forgot. Derivative of negative x is negative 1. That's why there's two minuses here. So now I've taken the derivative. Now I'm going to plug in again and see if it worked or if it's still indeterminate. If it was still indeterminate, I would do the derivative again. So wherever you see x, well, there's only one place. Put 0 there. But e to the 0 is 1. And I mean, you don't have to write that, but it's nice if you write it all out. So you just get negative 3 over negative 1, and please, please, don't leave it like that. That's positive 3. I am writing the positive for emphasis. You don't have to write it if you don't want to. Just write 3, okay? So things to be careful. Derivative of 1 is 0. Students forget it. This minus sign, students forget to drop it. Chain rule, students forget to do it. So that's exactly why it's there. And the same thing, B has a trig function. I think it was sine 2x or sine 3x or whatever it was. That same thing as a chain rule. But students forget to do it. So make sure that you're aware. Use a chain rule when you do the L'Hopital. This one is ridiculously easy, but we have to do it anyway. So I'm doing L'Hopital's. Note, I am writing lim because I have not computed the limit yet. I'm just going to take the derivative of that function, the derivative of the top. The derivative of 7x is 7. Derivative of 9 is 0. It's a constant. Derivative of e to the x is e to the x. Does not get any easier than this question. Now I'm going to plug in. So I don't write lim anymore. I'm plugging in. I'm going to replace the x with infinity. But e, right? E is like 2.7. You're taking infinite powers of 2.7. It's infinity. So you get 7 on top, which is a constant, over infinity. That's important you understand. When you divide a constant by forever, right? If you were to split $7 among an infinite amount of people that never stop growing, everybody gets nothing, right? So any number, I don't give a damn how big it is. It could be a million. A million divided by infinity is 0. Does not matter, right? The bottom is never going to stop growing, so the whole thing goes to 0. So that's what I'm testing there, right? You at some point on that exam, you're going to have like 1 over infinity, 2 over infinity, whatever. 7 over infinity, you're going to have to understand it's 0. So now I'm going to do the ones that really trick people. Okay, so I'm gonna do the word problems. I wrote this rather half-assed, but this is the one where it says the volume is increasing at a rate of 6 cubic inches a minute. The height of the cone is half the radius. I'm reading off the sheet that I have up. Find the rate of change for the radius when the radius is 4, right? I wrote this kind of sloppy, and you don't even. The point is it's number 6. Let me make sure it's number 6 and not number 5. That's number 5. I wrote number 6. All right, so it's number 5. So if you want to look at it, look, I'm only going to do the one cone problem because there's only going to be one cone problem. But the thing with the cone, first it's a tricky question, but there's two things that you can happen. You are either going to replace the R or you're going to replace the H. So they are slightly different. I don't know that one of them is harder than the other. So the volume of a cone is 1/3 pi R squared H. This is the reason you have to replace one of them. You're going to take the derivative with respect to t, time. And when you do that, you would have to use a product rule here, and you just wouldn't have enough information. But it's really simple. If they're asking you for the radius, you get rid of h. If they're asking you for the height, you get rid of r. It's very simple. Whichever one they're asking you for, you have to kill the other letter. So if look, they're telling you R is 4. That means H has to go. So now they tell you that the height is half the radius. So that's what you got to plug in, right? You're looking to take the derivative of this. So it has to all be R. So I have to get H out of there. So first I'm going to do that. I'm going to rewrite my formula. You have to do this carefully. Some of you do this very kind of half-assed. Just put 1/2 R, right? H has to go. 1/2 R is going to go where H is. Very simple. Now, I like to neaten this up before I do the derivative. I do this. I recommend you do this. You have 1/3 and 1/2. That is 1/6. The pi is not going anywhere. Stays there. I have R2 and R1. That's R3. This is your formula. That is what you are going to take the derivative of. So my advice is simplify the formula a little bit before you take the derivative. And now you're going to take the derivative with respect to t. So again, you should do this very, very carefully. Derivative of v is 1 dv dt, right? That is the rate of change for the volume. Well, they gave it to me. Volume of a cone is increasing at a rate of, over here, 1/6 pi, constant, leave it alone. Derivative of r3rd, 3r squared dr dt. Right? Now, I am going to neaten this up a little bit before I start plugging into it, because that's just what I like to do, because it makes it easier for me to plug in with smaller numbers. So I have dv dt. I have a 3 and I have a 1/6. I mean, it should not be a stretch for you in Calculus 1 to be able to reduce this fraction to me, right? 3 goes into 6 twice. You have 3/6, that's a half. So this 3 and this 1/6 combined to make a half. You got your pi. So now you just have r squared dr dt. Now, the original question said to you, the volume of a cone is increasing at a rate of 6. That means that, now I did tell you to do this first. And you're looking for the rate that the radius is changing over time. That's dr dt. So this is what you're solving for. They gave you r. They're telling you at the moment that the radius is 4, what is the rate that the radius is changing at, right? The rate is constantly changing. So, and they also told you that the volume is changing at 6. So I'm going to put 6 there. I'm getting close to the bottom, so I'm going to go this way. 6 for the volume, right? That's the first sentence that they give you. So you have 1/2 pi. I mean, at this point, it's plugging in. You really can't do this wrong. R is 4, but you got to square it. dr is what you're solving for. This is going to be very tight. So you have 6, 1/2 pi. 4 squared is 16 dr. And yes, it's dr dt, but I'm kind of running out of room, so I'm writing this. Now, I'm going to take half of 16. I'm going to have to even go over here because I'm really running out of room. So I'm going to cut the 16 in half and get 8 pi, right? Half of 16 is 8, and the pi is still there. dr dt, but dr dt is what I'm solving for, right? This is a product. Don't do a dumbass thing and subtract this. You have to divide this. So you're going to divide by 8 pi. on both sides. Sorry, it's sloppy. I'll write it neater here. So this is what dr dt is, but 6 and 8 are even, so you can cut them in half. Half of 6, half of 8. Now, be careful. The pi is not here, right? The pi is here. The pi is not here. The pi, that's what I meant to say. The pi, you divided by 8 pi. So the pi has to stay on the bottom. It's very easy to lose that pi and put it in the wrong place, and that's a mistake. To be very careful with this. Yes, the word problems are tricky. They're involved. Fortunately, there's only one problem with the cone. Same thing on the final. There's only one problem, and it is the one with the cone. So, it does involve a bit of work. You have to rewrite your formula so it's all the same letter. It's either going to be all R or all H, depending, right? If the third test has the one where you have all R, then the final will have all H. That's the way that they're designed. Like you'll do one where you replace H, one you replace R. So just like this, but if you have some common sense and you understand that I'm working the question in the video where you replace the H, then that's probably the one on the test. So, again, there's a lot of places you can go wrong if you're not careful. The derivatives with the simplifying. So just, again, take your time with this question. I would always recommend you do the word problems last on an exam. So that's just my advice. Now I'm going to do another word problem. Okay, so I'm going to share the screen quickly here just to so I'm looking at 8. The volume of a cube is increasing at a rate of 24. How fast are the edges or the sides of the cube changing at the moment that each edge or each side, I really should word that to say side. Edge sounds a little funky. Okay, so it says the volume is increasing at a rate of, right, that's dV. So they're telling you that the volume is increasing at a rate of 24. And again, don't worry about the units. Now, the volume of a cube, I mean, it's really simple. Length, width, height, but it's a cube. That means it's a square. So it's just x to the third. Very simple. I mean, it doesn't get any easier than that. Now, they're asking you how fast are the sides changing or the edges changing. That's dx. I mean, I'm calling them x. I would prefer you don't call them s. You can call them s, but I don't use s because my s tends to look like a 5. So I like to stick with x. It's the letter we use, but whatever. Some people call it side s, whatever. So this is what you're looking for. And they obviously they have to give you the x. So they're saying at the moment that the edge is 4. So then they tell you x is 4. I'm looking back and forth here because I don't want to leave it up on the screen because I have to write on the board. So again, you have this formula. Will I give it to you? I'm going to give you the cone for sure. I mean, they give you the cone on the final. But, I really want you to know the volume of a cube. If you didn't know the damn formula on the test, I would have to ultimately tell it to you, as ridiculous as it is. So if you forget the formula, any of the formulas that you might need, you just ask me and then I'll tell you grudgingly, but I will tell you. Derivative of v is dv dt. Well, it's 1 dv dt. Derivative of x to the third is 3x squared. Dx dt. I mean, it doesn't get any easier than this question. So the volume is changing at a rate of 24. I'm looking for the rate that the sides are changing at the moment that x is 4. And the last problem, you had to plug in 4 too. It's very similar to the last one. Dx dt is still here. So this is a little bit bigger. So you get 24. Here you're going to get 16, right? 4 squared is 16. And then you're going to times that by 3, which is 48. Now I see why I picked these numbers. So you're going to divide both sides by 48. This is exactly 1 over 2. This is 1/2. So this is the rate that the sides change. Okay? So, again, pretty straightforward. Now I'm going to show you something that I do only for this third exam. Okay, so I made up some completely fake formula. This is a formula that doesn't exist in the real world. I can prove it. Very simple. R cubed H would be 4 dimensions, so volume is not 4D. So I made up this fake formula. Now, why I do it? I used to have the problem with the triangle on the exam. The problem is it's long, it's a pain in the neck, and there's a lot of other stuff on that test. So the test is already very long, and I'd rather. My goal on the triangle question is to see if you take that derivative correctly. Because to do the area of a triangle, right? It's 1/2 the base times the height. You have to do the product rule. You can't, like the one with the cone is simple. You're going to replace H or R so you have the same letter. So it's easy to take the derivative, right? You have R cubed or you have H cubed, whatever it is. You have the same letter. It's trickier to take the derivative with different letters like this one. So what I did on the test, I gave you a problem where I give you this crazy weird ass formula and all I ask you to do is take the derivative with respect to time. Now you have to understand what that means. You have to understand I'm asking you for ddt. I mean, if you come ask me, I'll tell you. But some students just sit there and they don't understand. I did like, is that all you want? I was like, that's all I want. I want you to just take the derivative of this weird ass thing. So on this side, you would get dv dt or whatever I put here. I might put a letter. I might put y equals. Let's make it y equals just for fun. Let's say it's y equals. Then the derivative of that would be dy dt. Now on this side, now I might not even put 2/3 there. I'm just putting it there for fun. You have 2/3. Now I have to do first, second. That's the whole point of me asking this, is to make sure that you take this derivative correctly. This is a product. So you're going to do first times the derivative of the second. The derivative of h is 1 dh dt. Plus the second, which is h, times the derivative of the first, which is 3r squared dr dt. And now I'm going to neaten this up a little bit. So I have dy dt equals, now I'm going to put the 2/3 with each of these. I'm going to put the 2/3 here. So you get 2/3 r third dh dt plus, now be careful here. You have a 3 there. I want to write this in nice order. You have 2/3 times 3. Look what happens to the 3's. 3 divided by 3 is 1. So you end up with a 2 here. H r squared. I want to write r squared first, just for fun. And then dr dt. Just make it look pretty. That's all. That's a pretty tough derivative to do. Now, that's it. I didn't ask you shit. All I asked you was to take the fucking derivative. Just take the derivative. Do nothing else. Just take the derivative of that formula with respect to t. Time. Done. Product rule. It's tricky, especially if I put a fraction there. I probably did not do that on a test. I don't think I did. So, but I worked an example like that just to show you. But on the test, this is probably not even there. It's probably even easier. There's just something like r third h squared or some weird ass thing like that. And you just take the derivative from me. Very simple. I don't give you anything to plug in. I didn't tell you anything. Oh, this is changing, this is changing. The problem says, here's a formula. Find the rate of change with respect to time. That's all you have to do. So I'm asking you to take the derivative. So that is how I replaced the triangle question on exam 3. So I think that's pretty straightforward. And I think it's only worth like 2 or 3 points just because you're only taking a derivative. Okay, so that's that. Okay, so I'm going to do another word problem. And again, I'm going to share the screen just to make it easier to read it. So for number 2, box with a square base, open top, must have a volume of 500. Don't worry about the units. You want the dimensions that minimize the amount of material used. That is called surface area, right? It is the area of all the surfaces. So, I mean, you can draw the picture. I always have trouble, as soon as I draw it, what looks like the bottom to me just turns out to not look like the bottom to me. Like right now, it looks like that's the bottom to me. I mean, I could try to shade it. So that's the bottom. And the bottom is a square, but the top, right, the height is not going to be. And it's it's a box without a lid, right? You have no top. So this is what you want to do. So now the problem is that there's 2 different formulas. There's a formula for the volume, right? Volume is simple. It's like the room that you're in. The volume has length, width, height. But the length and the width are both x because the base of your box is a square. So this is going to be x squared h. Now, it's a problem because you're going to end up taking a derivative of something, and if the letters are not the same, you got a big problem. So here's another problem where you're going to be doing replacing. Now, I'm going to use SA for surface area, right? Each of those sides is a surface. Like if I just take like if this is the front, right? That side, right? That is the front. That's one of the 4 sides. The area of that, right? That is this. Well, it's not a square, but it's a rectangle. But that surface has area because it's flat, right? The sides of the box are flat. So it's XH, right? So you have four sides across. You have four XHs. The front side, the back side, and the other two sides. And then you have the bottom. The area of the bottom is just X times X because the bottom is a square. You don't have a top. So you only have five sides, bottom and the four around, right? And you're looking at the area of each of those surfaces. Right? Surface area sounds scary. It's like, what does that mean? But like I said, like if it's a sphere, right? The surface area of a sphere or a ball, like a baseball, if you peeled all the leather off and laid it flat, that's a surface and it has an area because it's flat. When you, like, same thing with the orange, you peel the orange and you put all the skin perfectly flat, then that's the surface area. So these are the two formulas. Now, I did say that the volume must be 500. And I want to use the least amount of material I can to get a box of that size. My box must be that size. I need the box to hold 500 whatever cubic centimeters or whatever the heck it was, inches. So I have to ultimately take the derivative of the thing that I am trying to minimize or maximize. Whatever they give you, right? Sometimes they'll say you want to do max this, min that. You don't have to worry about whether it's going to come out correct. Taking the, because, like, remember, you can get a max or a min. The derivative tells you both, but you just assume that when you do the problem, that the derivative is going to give you what it asked you for. It's asking you for a min, so this derivative will give you the min. So, in order to take this derivative, look, x, h, oh no, you cannot have this h here. But that's why you have that formula. I'm going to solve that top formula for h and put it here so I can take the derivative. So divide, right? This is a product. This is very important. You screw this up, the whole problem is over. You got a dot there, so you must divide. So I'm going to divide both sides by x squared. I mean, if you really want to see the move, I could write the move. I just don't want to destroy my formula. And then you would cross those out, right? So you would get h alone. I'm going to keep my formula the way it is, okay? Now, ultimately, at the end of this question, I'm going to need a calculator. This is why I'm either going to give you a number that's going to come out nice, or, I'll allow you to use one that I bring. I'll bring like some community calculators for the class and set them up in the front if people need to use it. So now, before I take the derivative of that, I'm going to rewrite it. Now that I solved for h, I took my first formula and I solved for h. So I'm going to do that just like that. H has to get replaced. Now, before I take the derivative of this, I must simplify it, right? You want to make it easy for yourself. You don't take the derivative the way this is. Now, there's a way to avoid timesing these numbers together, but I'm going to try to make pretty nice numbers. I mean, it's not difficult to do 500 times 4. You just do 5 times 4 and add 2 zeros to it. 5 times 4 is 20. And then you add 2 zeros to it. Hello, 500, 500, 500, 500. That's 2,000. Now, here you have an x on top and 2 on the bottom. Whoops, this is a plus. Sorry, too busy talking. So that x and those 2, right? If you had 1x and 2 x's, you end up with 1x on the bottom. Okay? Now, so that's the first step. Replace h, simplify. But I'm going to go even one better because I'm about to do a derivative of this. I will not take this derivative like that. You must have it in the proper form. So I'm going to take that x that's there, and I'm going to move it up so it's x to the minus 1. Remember, if you had 1 over x, and I asked you for the derivative of this, you cannot do it. You must write it as x to the minus 1 and then use the power rule, right? Multiply by the power, subtract 1. So that's now I'm ready. I replaced h, I simplified it, and now I'm going to do SA prime derivative. It's important. Make sure that you write the prime. All right, so that's going to be 2x, derivative of x squared. Here you're going to put a minus in the front, so that's minus 2,000, right? Multiply by the power, subtract 1 from the power. That's the derivative. This is a separate step. A lot of you don't do this as a separate step, and then you start writing equals 0 from the beginning, which is ridiculous. It's not. Now, you take your derivative and you set it equal to 0. This is another step. This is a separate step. but you must put equals 0 as a good chunk of students who don't write this down. You are solving for x. You need an equation, right? The max and min occur, right? Critical numbers. Take the derivative, set it equal to 0 is how you find critical numbers. So that's what I'm looking for a critical number. You have to set it equal to 0. If I don't see that there, and I write it for you, -1. It's very simple. It's very, very simple. Can't solve this question without that there. Now, now I'm solving for x. How the hell, I mean, if I'm telling you, x to the -2 equals 9 or something, you can't, how the hell do you solve this? This is ridiculous. You cannot solve an equation with a negative exponent in it. So I'm going to remove that negative exponent. And again, I'm running out of room, but I think I'll do it here this time. I'm going to rewrite it so that it's -2000 over x squared equals 0. Right? All I did is take this negative exponent and move it to the bottom. That's the rule, right? Now, I'm going to take this whole thing. It's equal to 0. I'm going to move this here. I want to be careful with my signs. I don't want to mess around with negatives. So I'm going to add this entire piece to both sides. So I get this, right? You just add it over. This way, everybody is positive. I don't have to worry about any crazy drama. Okay? So I did that move. Now you do the crisscross applesauce thing, right? You got to cross multiply. This has to cross over to that side. There's nothing to cross over to that side. There's a 1 underneath this. So you're going to get 2x to the third, right? You have x1 times x2 equals 2,000. Right? So you cross multiply. Now you have to divide by 2. I'm there. I'm at the end of it. Those 2's cross out. I know I'm running out of room. So you get x cubed, as long as you can still see it, equals 2,000 cut in half divided by 2 is 1,000. Now again, if you need, you absolutely have to do this. Or you could just come and ask me what the cube root is. But look, 10 times 10 is 100. 100 times 10 is 1,000. So 10 cubed, right? What does 10 cubed mean? 10 times 10 times 10. I have to give you a perfect cube here. This has to come out nice. I can't put a number here like, 5. It has to be nice. So that means that x is going to be the cube root of 1,000, but you don't even need to do that, right? It's 10. 10 to the third, right? 10 to the third is 1,000. So that means that x is 10. Yay. That means you're going to go all the way back over to here and figure out what h is. But if you remember what I told you in class, how these are set up, if the base is a square, whatever you get for x, the h will be half. So if I plug in right now and I don't get half, I don't get 5, I know that I screwed up somehow. I either screwed up this or I screwed up over here. So you're going to plug in 10 for x, and you see it's going to come out to 5. You get 500. 10 times 10 is 100. Cross out all those zeros, and h is 5. So the dimensions, because remember, the question says, what are the dimensions? The dimensions are length, width, height. So it's 10 by 10 by 5. And guess what that comes out to? 500. That's the whole point of this stupid-ass question, right? The volume has to be 500. I want the dimensions that give me the least amount of surface area, right? You want to use as little material as possible to make that box. So again, whatever you get for x, the height's always half of it, assuming the base is a square and assuming the top is open. If the top had been closed, they end up being equal, but I won't give you one like that because they tend not to give one like that. So, and that's not how, this is, I did the one that will be on the test, which is the box with the open top. Okay, so this is, again, the word problems are involved. They take time. They're easy to screw up. I would do the word problems last. That's just me. Okay, so now I'm going to do the problem with critical numbers, following up with this. Okay, the problem that would normally be sketch the graph of this, but on the test, to make it easier for you, I'm just going to have you find the critical numbers, where the function is increasing, decreasing, and the maximum and minimum. And that's enough. That's a lot of work. So again, this is not a question that you want to just dive in and do this one first. But I'll give you a strategy when we're all done. First thing is to take the derivative, right? I mean, it's Calc 1. Everything you do in this damn class, except the end, when you do antiderivatives, is always take the derivative. So derivative is going to be 3x squared minus 12x plus 9. And again, not to be mean, but if you take that derivative wrong, I don't know what the hell you've been doing the whole semester. So finding the critical, now that's step 1. Don't put equals 0 there. Okay, this is, I know students like to just put equals 0, but right, this is a separate thing. That's the derivative. Now I want the critical number, so I'm going to take my derivative and I'm going to set it equal to 0. Again, this is a separate step. I don't like the way my 12 looks. I'm going to rewrite it. I'll make my 2 the other way, right? I either make my 2 like this or like this, and I point this out all the time. That even within the same question, I write my 2's differently. It's just a weird thing. So now I have to solve this for x. No quadratic formula. I rig it so it factors. Why would I not do that? I mean, I have to have it factor for you. So notice that all these numbers are divisible by 3. So you can divide them all by 3, but remember, you have to divide both sides by 3, but that's 0, so that's still going to be 0. This is why this works out awesome. Divide away the 3, you don't need it, it's just an extra constant. So this, and remember, this only applies to when you're solving, is that you can divide the 3 away. So that gives you x squared, that gives you 4x, that gives you plus 3. Now I'm going to factor it. I know that since the last number is positive, my signs are going to be the same. And I know whatever is in the middle tells me what the signs are. So I'm going to drop that one. This one has to also be negative to make negative times negative is positive. There's only 2 numbers whose product is 3. It's 3 and 1, so there's no mystery here. So you get either that x minus 3 is 0 or x minus 1 is 0. And yes, even at this level, I'll let you skip this. But, you know, you don't have to write all this. I know that over the years, I've had students, even in Calc 1, ask me where I get x equals 3 from, and then I write it all out. So you could just cut to the chase. You don't need any of that. You can just tell me x equals 3, x equals 1. These are your critical numbers. Now the question is what you do with them. I don't know what to do with them. You put them on a number line like I told you. So you're going to put 1 and you're going to put 3. Right? This splits your number line into 3 regions. A left, a center, and a right. Out here is negative infinity. Out here is plus infinity. Now I'm going to be very, very precise when I do these. These are going to be my endpoints that I put in my intervals. Okay? What I need to do is I need to pick some test points. And I think I'm going to do this in green. I'm going to pick a number out here as a test point. Well, let's say I pick 0. 0 is a good test point. In the middle of 1 and 2, I mean, unless you're really sadistic and want to pick some weird fraction or decimal, you should pick 2. And out here, I'm going to pick my test point to be 4. Now, where am I going to plug those test points in? Right, you're looking for where the graph goes up and down. So that's the slopes of tangent lines. If the slope of the tangent line was plus, that meant the graph's going up, 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 up. If the slope is minus, then the graph's going down. So that means that you have to plug them into the derivative because the derivative gives you the slopes. Plugging these numbers into the original function is going to do nothing. And you certainly don't want to plug the critical numbers in. If you plug these 2 numbers in here, they're going to give you 0 because that's how you got them. All right, so I'm going to write my derivative. Now, this was my derivative. But I would rather write that derivative factored. Now, technically, there's supposed to be a 3 there. But this 3 doesn't change anything, right? My derivative, when I factored it, right, ignoring I had equals 0 there. My derivative is this. Well, it's that. I factored out the 3. I divided it away, basically. But technically, that 3 is supposed to be there, right? If it's not, right, the derivative has a 3 in it. Look, 3, 12, 9. So I divided it away when I solved because my equation was equal to 0. So technically the 3 has to be there. But will it affect the positive and negative? It will not. But I'm writing it anyway because it is supposed to be there. Okay? So you do, I mean, look, that's an example of where you have to be a little bit precise and kind of understand what you're doing. So my test points, I'm going to do them in green just to be obvious. I had 0, I had 2, and I had 4. Now, remember what I said in class. I don't care. I'm looking at that green, and I'm realizing it doesn't look nice. I'm going to switch to red. You do not care about the number. You care about the sign of that number, whether it's positive or negative. So I think green not looking good. Maybe I could have did blue. Okay, so my test points. I'm going to plug 0 in first, right? So wherever x is, you put 0. That's -3. That's -1, and I'm timesing them together, and I get a +3, and then you times that by a +3. That's why, see, this doesn't affect the sign, because this is a +3. When you multiply something by a positive, it doesn't change its sign, right? So that negative and that negative make a plus. Now, I don't care that it's 9. I know that over here I got a plus. So now I'm going to plug in 2. So here I get 2, take away 3. Here I get 2, take away 1. That's -1. That's +1. When I times those all together, right? Yes, I would get a -3, but I don't care about the 3 part. I get a negative there. Now you plug in 4 for x, right? Everywhere you see x in your derivative, you plug in your test point. That's +1. That's +3. So yes, that's +9. It gives you a plus. So that meant that this graph went up, down, up. So, and again, you could make that little rough sketch if you want to try to do it, right? The graph goes up, then it comes down, then it goes back up. That means that this is going to be max, this is going to be min. And you can tell this when you plug the damn numbers in. It's pretty straightforward. So I'm going to do all the rest of that work. I don't know where the hell I'm supposed to try to fit it. All right, so these are my critical numbers. So let's write the intervals down first, because that's the easier thing to do. I'm going to write increasing, and I'm going to write decreasing, right? Where the graph is going up. The graph is going up where I see pluses. So the graph is going up in this piece right here. That's why you see the red squiggles. That's why I put them there. So the graph goes up from -infinity to 1. Then it starts to go down. Then it goes back up again when it hits 3, and it goes up forever. So remember, you put U for union, because the union of two intervals, from 3 to infinity. So that's where the graph is heading up. It is only dropping between 1 and 3. That's why you put the numbers there. And again, super hint here. If the numbers in your interval are not your critical numbers, you messed up. I see students all the time put the test points there. They'll put 0, they'll put 2, they'll put 4. This graph is not going up from 4 to infinity. This graph is going up from 3 to infinity, right? The 4 was the test point, just to figure out whether it was positive or negative. That's not, has nothing to do with where the graph goes up. It goes up at the critical number. Now, I need the max, and I need the min. I know that I have both. This graph went up, down, up. So I have a high point and a low point. Now remember, those are called relative max and min, not absolute, right? They're only maximums relative to the rest of the graph, but you don't need to worry about that. Let's plug in 1 first, because it's probably easier. I need to do f of 1, right? I am looking for y now. If you want a y value, original function. Put my lighting. I had such good light, and then the light decided to go behind all the clouds. It was so bright and sunny, and then there goes the light. But this is why I have lights in the room. So I'm going to plug 1 into my original. Remember, f of x and y mean the same thing. Yes? When you were in pre-calculus, you learned that f of x and y were the same. So I'm going to plug 1 for all the x's. Very straightforward. And again, even without a calculator, it's not that bad. 1 cubed is 1. 1 squared is 1 times -6. 1 times +9. And then you have a +2. So let's see, you have 10 and 2, right? That's plus. 10 and 2 is 12. I like to do this. I like to add up the pluses first. And then I subtract. So you get 6. Now, I already know that that happens to be, right? The maximum occurs here. The minimum occurs here. So I know this is going to be the bigger number, but I'm going to wait. I'm going to just make sure when I plug in 3 that I get a smaller number than that, so that I know that I did it right. So I'm going to go back to my original function, and I'm going to put 3 there. So you're going to have 3 cubed. This one gets a little nasty. The numbers are bigger. But still, it's nothing. I'm not going to give you something unreasonable. I'm not going to make you plug like 17 in here. Can you imagine? 17 to the third. So 3 times 3 times 3 is 27. Over here, you have 3 squared, which is 9, right? And you're doing negative 6 times 9, which is 54. Oh, that's a little big, but that's not unreasonable. Over here, 9 times 3 is 27 plus 2. But check out what happened. This is really awesome. This is why I like to add up the positives first, right? That's plus 27. That's plus 27. When you add these numbers together, you get 54. And then when you add 2, you get 56. So you get 56, take away 54, which is just 2. So it actually comes out really nice. I mean, you just these all cross out, and you just get 2 left over. So that is indeed smaller than that. That means my maximum y value is 6, and my minimum y value is 2. All right, this is where my graph would hit the peak and then come back down. This is where my graph hits the bottom and then goes back up. That's the value. Remember, the max and min are values. I did not ask you for the point, right? You don't want, I mean, technically you can write 1 comma 6, but that's not, I didn't ask you for the maximum point. I asked you for the value. Like the question can be worded where it says find the max and min values. So I want the y values. I don't want the x's. All right, you already found the x's. You already found the critical numbers. You don't need to write them. All right. So again, this is another problem that takes a lot of work. These problems are long. That's why this test is difficult. It's a lot to keep track of, and we're still not done because we still have to do the antiderivatives. Although I think that's probably, besides L'Hopital, that's the more straightforward thing to do on that exam. Okay, so toward the end, the last topic is antiderivatives. I mean, and that's the end of Calc 1. This is where Calc 2 picks up if you have to take it. You start, that whole course is about antiderivative. Integration is much more complex than taking derivatives. However, you have to do this type of problem on your test. Now, I pulled the one off of the practice test because I like that one better. I'm going to work a few of them just to show you how to handle them all to make sure that you can, because we didn't have as much time in our class to practice as I would have liked. So, and is it easy? It's not hard, but it can be tricky because especially when there's fractions and the powers of fractions. Now, I altered this question. On the practice, the last number there is an 8. I deliberately put pi third there to try to screw you up here. So I changed that. This was an 8. You'll see how. Now, so I'm going to do antiderivative. Now I'm going to do them very carefully, one at a time. I'm going to add 1 to the power. These are all whole numbers, so it's pretty straightforward. I'm going to add 1 to the power. Now, I told you what you can do. Yes, you add 1 to the power, you divide by the power. That is overly complicated, and it's going to screw up a lot of people. Add 1 to the power. Take that power, flip it over, and put it in the front. See how much easier that is? Look at that. Over here. Add 1 to the power. Right? There's already a 2/3 there. Add 1 to the power. Flip it over, put it in the front. Very straightforward. Plus, add 1 to the power, comes x3. Flip that over, put it in the front. There's already a 9/4 there. So I'm going to put 1/3 there, right? Multiply. Over here, again, add 1 to the power. Flip that over, put it in the front. There was already a 7/6 there. And now that one is just a constant. Now, when you took the derivative of a constant, you got 0. But here, you're doing an antiderivative. So you just add an x and then you remember your plus c. Not going to have a heart attack if you forget it, but you should try to remember to put the plus c there. Now I just have to simplify this. All right, so these 6's cross out. 6 divided by 6 is 1, so I get 1/5 x to the 6th. Over here, I'm going to cross out the 2 into the 4, right? So you get negative 1/6 x to the 4th. This is death for some students. I mean, you have to be able to do this at this level. 3 is going to go into the 9, right? So that gives you 3 on top, 4 on the bottom, x to the 3rd. Here, nothing crosses out. So you multiply the numbers on the top, you multiply the numbers on the bottom. And, if you really need a fraction review, and I already did that one, go back and watch my 065 playlist for, when I would show my remedial students how to do this, because I know that they would have fits doing this. I would tell them, just write 9 as 3 times 3. and then just cross out the numbers that are the same. Straightforward. But even in calculus, students, no one likes fractions. They're a pain in the ass. Students do it wrong. But this, because you are adding and dividing, right? You add 1 to the power and you divide by the new power. Because you're dividing, and it creates issues because you might have a power that's a fraction and you might have the number in front, right? The coefficient being a fraction. So it adds a layer of complexity to this that really shouldn't be there, but it is there. So the way to avoid that is to do what I'm suggesting you do. Do you have to do this? No. But it's easier to just take whatever this is, flip it over, put it in the front. It is the exact same thing if you had just done this. But the problem is I see students screw this up all the time. And then even if you do that, you still have to go, right? 6/5 divided by 6, keep, change, flip. I mean, it's just why go through all of this when you could just do that in the very beginning? So that's why I advise you to do that. Now I'm going to do a few more. I'm going to do ones with that have roots and radicals in them. My computer is too far from me, so I got to pause it. Okay, so this time I went back to the review sheet. I mean, I don't think the practice one even has 11 questions on it, but or maybe it does. So this one is from the review sheet, so it's 11D. Now, I'm looking at it and I noticed something that I wouldn't do on a test. This is a cube root, this is a cube root, and I'm not going to do that. So I'm going to change this question. So now this is going to affect the answer. Obviously, you do the one that's on the sheet, but I know that when I make your test, here's your test. That's not your test. That's your half-finished test because I tinker with it to the last possible second. So I know for a fact I will not give you 2 antiderivatives with the exact same root. I just don't do it. So that, and that's an oversight. That's my fault. On the sheet, that one, and I will change it, but it's a little too late. So you do it the way that it is on the sheet. But as I do it, you're gonna see that the answer is not gonna match the sheet because I just changed the damn question. But these are going to be the same. Now, before you even do this integral, right? This is called an integral. That symbol, antiderivative integral. I'm going to rewrite everything in a form that I like. Now, that is x to the 4th. Look, x to the 4th. I mean, you see x to the fucking 4th. So this 3 had to go somewhere. It doesn't go on the top. This is not like, I'll see students write this down. And I'll ask them if that makes any sense. Right? I'll ask them, the students will take this and they'll write this. And I'll say, but you see x to the 4th is right there. This is x to the 3rd. If you took away this 4, how the fuck is this the same as this? It makes no sense. So you have x to the 4th power and then the root is 3. So it goes like that. Now this one, you gotta be very careful. This time it's on the bottom. Again, you see x to the 5. So you write x to the 5. And then that 4 is the root, so it goes on the bottom. But I cannot leave it like that. I have to move it up, right? You can't, it's just like the derivative. You could not take the derivative of that the way that it's written. Back in the day when I was asking you derivatives, you cannot take this derivative with the power rule. Students be like, oh, multiply it by the power, subtract 1. That's total nonsense, and it's wrong, right? You had to rewrite this like that, right? You had to move this from the bottom up by switching the exponent and making it negative. So I have to do the exact same thing here. So I'm going to do it to save myself space. I still have a 2 times, now that's going to be x to the negative 5 over 4. Right? It was on the bottom, I moved it up. Now, don't forget my dx. Why is the dx there? Remember, this thing here is a derivative. That's why the dx is there. I started with some function and I took its derivative and I got that. I'm trying to reverse it and figure out what I started with. That's the whole point of antiderivative. What did I begin with? So when I see this dude, I ask myself, whose derivative did I take that gave me secant squared? And this is why if you don't memorize the trig derivatives, I mean, again, what have you been doing the whole semester if you're not going to remember that the derivative of tangent is secant squared, right? The derivative of cotangent is negative cosecant squared. So his antiderivative is tangent. Why? Because the derivative of tangent is secant squared, right? If you take his derivative, you get that. This is the derivative. This is the original. So now, this one is a lot more complicated. I have to add 1 to the power, so I'm going to do it on the side. I have to add 1 to this exponent. So in order to do that, I have to make the bottoms the same. So I turn 1 into 3/3. So my new power is going to be 7/3, right? 4 plus 3, don't be a dumbass and add these 3's again, make a 6 there, right? So you get 7/3, right? That's adding 1. Now, you're supposed to divide by the new power, but I told you, just take whatever this power is, flip it over, and put it in the front. It's that frigging simple, and it works every time. It's beautiful. Okay, so that's that one. Let me make an arrow, and now I have to do this one, right? I have a 2 there. Now, I'm not going to put a sign yet because I see what's going to happen. My power is -5/4, and I'm going to add 1 to that, right? This is how antiderivative works. But I'm going to turn the 1 into 4/4. Why? Because I need the bottoms to be the same. And I can turn 1 into anything I want. 2/2, 3/3, 4/4. So now add them together. -5 plus 4 is -1. So that's my new power. -1/4. So my power is going to be -1/4. Now I have a 2 in the front. And I told you, take this power, flip it over. When you flip -1/4, you get -4. And there was already a 2 there. Right? You're flipping this over. How do you flip this? The 4 goes up, the 1 goes down. But it's still negative, isn't it? There's a negative there. So that's -4. So you put that in the front. But there was already a 2 hanging out waiting. So that's going to give me a -8 in the front of that. And then don't forget the plus c, the constant that could have been there. Don't know what it was. There you go. If you were to take the derivative of this dude, you get this dude, which you can write as that dude. Right? You can take your fraction powers and write it back like that. Please, for my sanity of grading, I want it left like this, and I want it left like that. I want you to leave. And I know for a fact there are colleagues of mine who give their students tremendous crap and say, you do not leave it like that. You got to write it as a root. You got to write it as 8. Now here's 8. I'm even making the voice. 8/x to the 1/4 power. I will be very, very unhappy if you do that. On this answer is exactly how I write the answer on my answer key. I will not rewrite them with the roots there. It's unnecessary. It's pointless, right? You've already shown me that you understand that this is this by rewriting it for me before you took the antiderivative. So why do I have to make you put it back that way? I won't. So again, please, I'm emphasizing this. Please, leave your answers with fraction powers and negative powers. Do not rewrite them. Okay, now I'm going to do another example of this because we can solve more negative powers. Okay, so this is going to be the last antiderivative that I worked, the last integral. And then I do want to, there's one I'm looking at my my mock test here. I mean, I don't change it a whole lot, but I know that I'm going to make changes to what I have in front of me, but that doesn't mean I'm not going to tell you some secrets in a little bit. Secrets always come at the end. So just like the previous antiderivative that I did, the previous integral, I have to rewrite it first. So I'm going to do that. I need to bring this one to the top. This is pretty straightforward though, because it's already a whole, it's a whole number. I don't have to do any rewriting. This one I do. So now remember, a lot of students forget what that power is. Remember, there is an invisible 2 there. That number is called the index. I never use that terminology, ever. The x that's inside there is called the radicand. I don't use these terms either. I don't like these words, so I don't use them. All right, I just say inside and, the little number there in the ribbon. So there's supposed to be a 2 there. Now, that's x to the 1, isn't it? I mean, that's x to the first. So when you rewrite that one, it's really x to the 1/2 power, right? That's what square root means. 1/2 power, square root. So now I'm going to move that one up because I need to use the reverse power rule on it. So I have to rewrite it. This one you don't do a damn thing to because it's a trig function. So you just have to figure out whose derivative that was. Remember, you're going reverse. So now, again, this time I'm going to be a little more careful with this. You have to add 1 to the -4. So it becomes -3, right? Now, I've been telling you to take that and flip it over and put it in the front. And that's great. You can do that. But in this case, look, whole number, right? Whole number, whole number. So in this case, you actually can put it underneath it, and it's not going to mess with it, right? You add 1 to the power, boop, boop, you get that. And then you divide, see, whole number, whole number. So you can still do a flip and put it in the front. That's fine. But in this case, when I do these myself and I see that they're both whole numbers and they're not fractions, I will just divide it flat out. And that gives me -2 x to the -1/3. It's the exact same thing if I had just taken that, like I said, flip it, put it over there. That's still 6/3. It's still the same damn thing. It's just slightly easier to just put it directly underneath. Now this one, I won't do that. So I am going to put the plus because, well, you know what? I won't do that yet. I know it's going to be plus because I know when I add 1 to that, it's gonna be positive. So I have 1/2 and I add 1. So -1/2 plus 2/2, right? Turn the 1 into 2/2. So that becomes a half. So the new power is going to be +1/2. Now I can put my plus there because now I know I have a +4 and I have a +1/2. So I know that this is not going to be negative. So I'm going to take that power, since it's a fraction, I'm going to flip it over, right? If you flip 1/2, you get 2/1. I'm going to flip that power over, put it in the front, and I'm going to hook it up with the 4 that's already there. That's going to give me 8x to the +1/2. And now I only have to worry about this dude. So I go back to my derivative list. Derivative of sine was cosine. Derivative of cosine was negative sine. Derivative of tan, secant squared. Derivative of cotan, ooh. So now, this is where you got to be careful. The derivative of cotan is negative cos squared. Look what you have. If this had been plus, different story. But it's not. It's a minus. So whose derivative was that? Positive cotan plus c. Now you can check this, super easy. Take that derivative and see if it matches this. It does. The derivative of cotan is negative cos squared. If I put a negative here, the derivative of cotan is negative cos squared. That would have created a positive here. It does not work. So this had to be plus. And I will see students, so here, little bonus for you. Because it's easy to mess up. Like I'll put sine x here. And I'll ask you for the antiderivative. I'll ask you to integrate that. Now what students will do is they'll just put cosine there. Plus c, but I don't care about that right now. Right, they'll put cosine. But the derivative of cosine is negative sine. There was not a negative here. So you have to put it here. So you have to be very careful when you're going in the opposite direction. When you're doing the integrals, the antiderivatives, you have to really watch your signs and pay attention to what you're doing. Because remember, you're doing the reverse of what you did before. But as long as you still know the 6 trig derivatives, you're fine. Now, something that, I'm going to go off the sheet here. For sure, I'm going to ask you to do something like this. I'm going to try to do them together because it's easier. When you do the antiderivative of that, you remember that the derivative of e to the x is e to the x. So that it's so simple. But I will have it there. I cannot ask you to do this yet. This is a lot more complicated. This is a Calc 2 thing. This is an integration technique. It does have e to the 2x in the answer, but it's not e to the 2x. So I have to give you a simple one. Now this one, if you were to do the power rule on it, right? If you rewrite that, this and this are the same, right? That's x to the 1. Move it up, -1. If you add 1 to the power, you get x to the 0. You cannot divide by that. This is undefined. So you have to remember that when you see this, it's our old buddy ln. And I know that'll be there. That's going to be one of the ones that I have. So you have to make sure that you understand how to integrate that. Okay, now I am going to do, I want to go back and do another L'Hopital one that I missed, and then I'm going to give you some secrets. Okay, so I went back to the beginning of the sheet to pick one, because I forgot I wanted to do one with ln, and I didn't, because it also involves a chain rule, and people mess up ln. Now, one important thing to remember about ln. The natural log of 1 is 0, right? It's the power of e, right? Remember that e and ln are inverses of each other. It's the power of e that gives you 1. That's why it must be 0, right? They're inverses, they're opposites. So ln 1 is 0. So if you put 1 here, you get 1 to the 4th, which is 1. So ln1 is 0, so you get 0 on the bottom. 1 to the 10th power. I don't give a damn what power you raise 1 to, you get 1. So you have 2 times 1 minus 2, so that's 0 over 0. So it is indeterminate. Do you have to show that to me? No, you don't. As I pointed out earlier in the video, you don't have to if you watch this far. So you don't have to show me zeros. You can write it. Just make sure. I'm not going to give you one that's not indeterminate. Why would I even do that? I want to make sure that you can do L'Hopital rule. So you're going to do the L'Hopital rule. You're going to write lim x goes to 1. Why are you going to write that? Because I haven't plugged in yet. The derivative of the top is 20 x to the 9. Derivative of negative 2 is 0. It's constant. Now you got to be careful here. Remember how you do ln. It's du over u. Not 1 over u du. That's some of you were doing that back in the chain rule day. But 1 over u du is du over u. It's the same fucking thing. It's just easier to do this. So whatever's here, I put on the bottom. Whatever's here, right? If you want, I'll write it there. Whatever's here goes on the bottom and put his derivative on the top. That's simple. Now, don't leave it like this, right? Look, I'm going to do it like a moron. You have x cubed over x4. Hello, 3, 4. Look, zoop, zoop, zoop. You're left with 1, right? 3 minus 4, get the x on the bottom. So, but be very careful. This looks like this now. Now, you might say to yourself, I'm going to simplify that. Keep, change, flip, this. I'm going to erase this because I don't need it. But look, your next step is to plug in. Can you simplify that? Yes, you can. You're like, oh, I'm going to divide the 20 by the 4. I'm going to flip the x up there. And students will do it. Plug in. Just plug the fucking numbers in and see what happens. Don't waste your time, right? Time is a factor on this exam. So jump right in and put 1 everywhere you see x. Replace all the x's with 1. Look what happened. Look how nice. You don't have to simplify it. 1 to the 9th is 1. So on the top, you just get 20. 4 divided by 1 is 4. See how easy that was? You just put the 1 in there. 20 divided by 4 is 5. Pow. That's my limit. Done. You don't need to simplify it. I know for a fact students will. They'll sit there and they'll write this. They'll write that. Divided by 4 over x. Then they'll put 20 times x over 4. Then they'll put 20 x10 over 4. Then they'll write 5x10. Then they'll plug in. Why the fuck would you do all of this? It doesn't make any sense to me when you could just plug in right there. Derivative, plug in. That's what I taught you when I showed you L'Hopital. Take the derivative, plug in. Don't do any extra shit. You do extra stuff, then you make mistakes, right? You want to keep it simple. Now, secret time. All right, so I don't mind sharing some things. Now, I know for a fact that this test is going to change from what I have in front of me. As of right this second, I have a L'Hopital where there's 3 of them. I'll even show you. Oh, you're losing it. 3. And then there's 3 more. So usually the L'Hopitals, because they're quickies, 2 points each. My advice to you, as soon as you get that test, they will not be on the same page, by the way. And the answers will not be the same. Like if you're doing if you're doing those top 3 L'Hopitals, people are going to be pausing the video. It's like, oh, those. They're not going to be the same. I change them every semester. Every semester, your test is not done. This is an old test. I use it to make the new one. And I always am unhappy with an old test. You have to understand this weird thing about me. I'll look at the test and be like, I don't like that one. I don't like that one. I start changing it. So even if you had the old test, they're not the same. They're good. They're great to study from. But that's the whole point of the review sheet. The review sheet is the test. So, but 2 points each. The answers will not repeat. Get that exam. As soon as you are handed that exam, find whatever page the L'Hopitals are on and bang out all 6 of them. There's 3 and then another 3. It might be 3 and 5 depending on the points, but there's at least 5 of them all together. They will not be in the same question. It's either going to be 3 and 3 or 3 and 2, and they'll be on different pages and the answers won't repeat. So if you got an answer of 2 on that L'Hopital, that doesn't mean the other ones won't repeat. But like if you had the L'Hopitals and it was A, B, C, and this answer was 2, and this answer was 0, this answer would not be -2. It would not be 12. It would not be 22. It would not be 32. I don't like the 2 to show up again. This answer might be something like a 5 or a 4 or a 3 or 1/3, something like this. Maybe you get a third there. The answers are going to be something like that. They're not going to repeat. So you bang out those L'Hopital's, get those, 10 to 12 points, depending on how many there were, right? 2 points each. Very, very fast. I would then go and do the antiderivatives. Now, how I have that on your test, I have 2 separate ones. One, I gave you one kind of long one where there's, let's see, 1, 2, 3, 4, 5, 6, 7. I have 7 terms. Find the antiderivative of each of those 7 terms. And it's not, it's not bad. It's something, I'll give you an example of what it looks like. I mean, it's something like this. You have x7 plus 2x6 minus 5x4 plus whatever. You have like 7 things here, but it's this simple. And maybe there's like e to the x there or something, and maybe a trig guy. And then you just do them one at a time. So if this problem is worth 7 points, they're each worth 7. So you just do boom, boom, boom. You just integrate each one at a time, right? You have 1/8 x to the 8th. Over here, you'd have 2/7 x to the 7 or whatever. Over here, you'd have minus x to the 5th, right? You had 1 divided. So you have one like that. You have a long one that's worth 7. And then later on in the test, you have one that's an A and a B where you have 4 things and then 4 things. So this one is going to be, I do have 4 and 4. So you have 4 things and 4 things. You integrate. Now, these are going to have roots in them. Like one of them will have like negative powers in it. And I'm just making up a question. So it's not going to be, but it's, and then like a trick dude. So you'll have one where you get a bunch of negative powers. That's ln, like I did before. And then the other one is going to have a bunch of roots in it, like, something like this. Again, I'm just making this up. This is not exactly what's there. And like I told you, I like to make them different. These numbers won't be the same. The roots won't be the same. So you'll have like 4 of these and 4 of these. So that's going to be 8 points altogether. All right. So that I would do the L'Hopital and then I would go do the antiderivatives, do the integrals. They're worth a big chunk of points. I mean, if you think about that, the L'Hopital is 10 to 12. I mean, it might be 12 if I have 6 of them there. It depends. I might have to chop one off and make it 10. But that first integral is 7, and then the next one is 8, so that's 15. That's 25 points out of 50. That is half of your exam is antiderivative and L'Hopital. The rest of that test is related rates, right? The cone, possibly cube, possible snowball. I have not decided yet. On this particular test, I had the cone and I had the cube. Maybe I'll keep the cube. Maybe I'll make it sphere. Maybe I'll make it, the snowball. I don't know. I haven't decided yet. This is what I decide during the week as I'm thinking about what I want on your test. All right. You have the box optimization problem with the volume of the box and the surface area. That's there. I might have the farmer with the pasture. I might not. I might not even put a second optimization there. It all depends on how your test spaces out and how the points fall out. I might have the one with the farmer and the pasture where you're fencing next to the river, right? And you do this dealy. And, the farmer has 2,000 feet of fencing and you want to maximize the area. That could be there, but it might not be there. It was on the old test. Doesn't mean I'm going to keep it there. I might not. So I haven't decided yet. But if it is there, it's not that difficult. And that you have the problem with the critical numbers. And again, if you look at mine, you see I gave you the fill in the blanks again. You're going to write increasing, decreasing, max and min. That's what I want. So, there's not a whole lot on that test, right? All the L'Hopital, the antiderivatives, which is that's half your test. And then the related rate problems. I will not have the triangle there. Triangle's not there. I told you what I do. I give you a formula. And actually, I'm reading my old one. It says, suppose a particle is moving along the curve. So I called it, I did something like this, like it's z equals like x to the 4th times y. And it just says, it reads exactly how it's worded, where x and y change over time. Find the formula for the rate of change of z. So I'm asking you for dz dt. So you just have to take the derivative of this, but the derivative of that is a product rule. By the way, it's not exactly this, but it's similar to that. Really, how How hard is it if I make that like x squared or x to the third or x to the fifth? Ooh, it's totally different. So, that's the other, related rate type. That's how I avoided doing the triangle. Remember, I didn't want to put the triangle. It's a lot. It's too much. It's too much on that test. There's already a lot on that exam, and I'm always very mindful about keeping my tests around an hour. Right? You have an hour and a half. If you're in a Saturday class, you have almost 2 hours, which is unfair to Tuesday, Thursday classes, but that's neither here nor there. So, I try to keep the test doable in about an hour. If it takes me longer than 10 minutes to do the test, too long. Right. So I take your test and I time myself and I write everything out very carefully. I make my answer key and I time myself. If it took me like 14 minutes to make the answer key, that's too long. If I can make the answer key in about 9 minutes or less, 10 minutes, then it's a good length exam. It's exactly what I do. I put my stopwatch next to me and I start making the answer key. I do the test. And I don't skip steps. I write it all out. Can I do that test in like 90 seconds? Yeah. But, it's not a race. I want to do it nice and slow and careful and write everything out and I time it. So, the point I'm making is the test has some tricky stuff on it and it can be long. Save the word problems for last. Now, you can ignore my advice. I do try to space them out so that they end up toward the back of the test, but they may not end there. I do try to put like the L'Hopital and the stuff on the first page because I know a lot of students will just get their test and they just go to problem one and then problem two and then problem three. But if you want to be a good test taker, there's nothing wrong with going through the whole test, looking for the easy ones, and banging them out quick. Right? There's strategies to take tests that make people better test takers. That's one strategy. Read the whole test. Don't even fucking, people just get tested and they just go to number one and start doing it. Stop. Take the test. Open it up and look through the whole thing. Read all the questions. Make sure that you know how to do them. Go back and do the ones you can do fast and easy, like the L'Hopital, like the antidiuretics. Then go back and do the harder ones. Right? I mean, if you want to optimize your grade, right? Optimization. You want to maximize your grade. You want to get the highest grade you can. Do all the easy ones you're going to get the points on. Do them slow and careful. You don't want to do the hard, long questions and then see that time is ending on you. And then you got to go back to the easy ones and race through them really fast and make a bunch of careless, stupid-ass mistakes and lose points you wouldn't have lost. So that's my advice to you on this test. All right. I will probably give you some type of formula and hint sheet. Give you like a little cheat sheet that has like, the formulas with, the cone and the sphere and all that stuff. I don't expect you to remember the surface area of a sphere. I do expect you to know the volume of a cube, but I'd give it to you anyway, probably. But, and stuff like that. So you'll have a little bit of a cheat sheet for the test to try to help you out. And again, the strategy, I basically covered in this video. It's ridiculously long, and I understand that, but I've covered everything that will be on that test. All right. Yes, I didn't actually work this question, but it's in the video, another video. So, but I didn't work it because I'm not 100% that I'm going to put it there. I work the ones I know for a fact are going there. Cone is going there, right? The box problem with the surface area is going there, right? I mean, I work the ones that I know for a fact are there. The critical numbers, increase and decrease in maximum, that those are there for 100% certainty. So the problem with the farmer and the fencing may not be there. So I didn't do that one. So, right? Okay. So again, hopefully, you stayed and listened for the secrets and, hopefully, I mean, I showed you the old test a couple times and you pause and try to zoom in and see what the questions were. But, I do change them ever so slightly. So, but if it helps, whatever. So all I can say is good luck on the exam. Make sure you're prepared. This is not an exam you come unprepared for. You will fail it badly. You won't just fail it. You will bomb it very badly. So good luck to all of you.